All right, guys. So this is Tuesday, 512, factoring and solving. So you're going to copy down every one of these problems into your notes. You're going to submit your notes as a grade, and then you're going to have 3 problems to turn in at the end that you're going to work on your own. So we need to factor this quadratic. This is a quadratic because it's raised to the second power. So this is what makes it a quadratic. Now, this is a binomial. So we know we don't want to do big star or diamond or anything like that. We're not going to come out with 2 factors that are binomials because this is only 2 terms. So since it's a binomial, you want to check for GCF. Ultimately, GCF is what you want to check for first every time. So looking at a 4 and an 8, they're going to have a 4 in common. So I can pull out the 4, and I end up with x squared plus 2x, because remember, this is whatever if I divided out a 4. So 4 times x squared would give me 4x squared. 4 times 2x gives me 8x. So that's why this is a GCF. Now, if I look at this again, so I look at my binomial here and here, they both have an x in common. This is my lowest exponent, so x to the 1 power. So all I can pull out is 1x at this point. And this is basically our hockey stick method just written in parentheses form. So this is our GCF for the whole problem. So 4x and then x plus 2 are our leftovers. So this is factored completely. So this is factored completely. Now that we factored it completely, we want to solve it. And by solving it, that means we're going to take each factor. So if it was 2 binomials, then both binomials. But in this case, our GCF, set it equal to 0, and then x plus 2, and then set it equal to 0. We're going to solve, so we're going to divide by 4 because that's the opposite of 4 times x, and x is going to be equal to 0. And then we are going to solve. We're going to subtract 2 from both sides because that's a positive 2, and x is going to equal a negative 2. So from your video yesterday, our solutions are going to be 0 and negative 2. As an ordered pair, that's going to be 0, 0, and negative 2, 0. Both of these ways are correct. You just have to figure out which way they want you to answer it. So if this happened to be on a graph, if we were looking at this quadratic, it's positive because the value in the front is positive. There's not a negative in the front. And a positive quadratic is always a smiley face. So it's going to look like this in some form or fashion. So from this information right here, I know that at 0, 0 is going to touch the x-axis, and then at negative 2, it will touch the x-axis. And it's a happy face. And for now, we don't know how far up or down it goes. But you do know it's going to cross the x-axis at a negative 2 and at a 0 because you solved it. So we have our factored. This is our factor. These are our solutions, also known as x-intercepts, also known as, solutions, x-intercept, answers, or zeros. So all 4 of these words are asking for this. And this is the same thing as just written in ordered pairs. All right, so that's example number 1. All right, example number 2. We're looking at a trinomial this time. Still a quadratic because it's written to the second power, but it's a trinomial. 1, 2, 3. You always want to check for GCF first, especially when A is not 1. So in this case, A is not 1. And when I speak of A, I'm talking about ax squared plus bx plus c, which is the standard form of all quadratics. And if they don't write equal 0, it can be assumed that it's equal to 0. So ideally, we would like this to be 1. So I'm going to check a 5 first and hope that I can take out a 5. So that's going to leave me with x squared. 5 times what gives me 20? It's going to be 4. It's a minus because there's a minus there, and then an x. And then 5 times what gives me 60? So that gives us a 12 at the end. So 1, 4, 12. There's not a better number. If I look at my x, there's not an x in the back. So my GCF is 5, so we're good here. Now, don't stop. We've not factored completely. That is only factoring out the GCF. As soon as you see this trinomial inside the parentheses, you are not done. This is where we're going to do our big star or diamond. Again, the star is just getting out of making the circles. So remember, multiples go on top, add goes on bottom, and our factors go on either side. So A times C, so 1 times 12, so our negative 12 goes on top. B goes on the bottom. Then we're doing our ACB chart, because that's what they call it in all the other math classes. So the multiples of 12, they'll add or subtract to give me negative 4. So this should be add or combine. So I have 1 and 12, 2 and 6, 3 and 4, and then no more. 1 and 12 will either give me 13 or 11, depending on if we add or subtract. 2 and 6 will give me 8 or 4. That one's looking good. 3 and 4 gives me 7 or 1. So we definitely want to be looking at this pair because it gives me that 4. Now, is your B value, so is the B value negative or positive? Because it's negative, the bigger factor is going to be negative. So we're going to make this a negative 6 and a positive 2. So these two guys are our factors. So we want to make sure we hold on to our GCF. And then we're going to write our factors. So that's x minus 6 and x plus 2. And we know the x has a 1 in front of it because the x has a 1 in front of it here. So we have now factored this quadratic completely. This is factored completely. But if it asks you to solve what are the x-intercepts, what are the answers, what are the zeros, you have to keep going. So you're going to take your factors. If I set 5 equal to 0, can 5 ever equal 0? Is there anything I can do to that 5 to make it a 0? Since there's no x attached to it, this is not even a conversation. So we're going to take x minus 6, set it equal to 0, and x plus 2, and set it equal to 0, and solve. So I'm going to add 6 to both sides because that's a negative 6. So x is going to equal to 6 minus 2 from both sides. X equals a negative 2. So as a list, should be a positive 6 and a negative 2. So that should be a positive 6 and a negative 2 as our solutions. As an ordered pair, either 6, 0, and then negative 2, 0, because these are x values. They go in the front. Those are our solutions, our answers, our x-intercepts. And both ways, it just depends which way it asks you. Which way it asks you to write it, they're both going to work. Now, again, that means that if this was on a graph, I know that at positive 6, it's going to cross here, and then it's going to cross at the negative 2. Now, at the beginning of this quadratic, it's a positive 5, which means it's definitely going to be a happy face because it's a positive quadratic. So that means it's going to go something down here, turn, and then come up. It's going to go this way. But it's going to touch your x-axis at that positive 6 and that negative 2. All right. Pause the video if you need to get some of this information because I'm going to go into our next example, last example. All right, look at number 3. Again, A is not 1, so that's the big thing. It's a binomial, trinomial. There's 3. So that means I know I'm going to need to use my star eventually. And since this is not 1, we want to check and see if there's a GCF. There doesn't have to be a GCF, but we're hopeful there's a GCF. So I'm going to try to make this a 1. So I'm going to pull out a 2. So x squared minus 4x minus 12 equals 0. 1, 4, 12 are all good. If I distributed this back through, it would work. So we factored out our GCF. We, again, are still dealing with a trinomial. So we can factor him using our star and our diamond and our ACB chart. So C goes on the top. And then the multiple side of our table. B goes in the bottom and on the right side. So the combined, add, or subtract 3, negative 4. So again, we got 12. So 1 and 12, 2 and 6, 3 and 4. 1 and 12 is going to either give me 13 or 11. 2 and 6 is either going to give me 8 or 4. Looking good. And then I have 7 or 1. So we're looking at the same set. That's 6 and 2 again. Because it could give me that 4, and that's what I need. I need a negative 4 because B is negative. So the biggest of these two, again, is going to be negative. And we're going to take our 2. So it's going to be x minus 6, x plus 2. So now we factored it completely. And that's just completely coincidental that it happened to be the same one. Sorry, I didn't mean to give you one. I was going to give you the same factors. But this is where you would call this factored completely. So if all the question says to do is to factor or factor completely, you could stop right there. If you stopped at the step before where all we did was do GCF, you did not factor it until you cannot factor it anymore. You need to go until you can't go anymore. Now to solve, we're going to set all these equal to 0. Can I turn that 2 into a 0 without multiplying it by a 0 or doing anything to it? No. So he's out of the conversation. So x minus 6 equals 0. X plus 2 equals to 0. We're going to add 6. So x equals 6. We're going to subtract 2. And x equals negative 2. And yes, for your notes, I want you to write all that down. All of it down. So then our list would be a 6 and a negative 2. Pause the video and write those as ordered pairs for me. So that means that this graph is going to touch on the x-axis at a positive 6 and a negative 2. That's a positive 2x squared up here in the front. So that means we know it's going to be a happy face. It's going to come down and make a U and come up and cross the x-axis there. All right, so you need to make sure your notes are thorough and you have all 3 of these written down. Take a picture and submit it. Then for you to do today, for your work that you're going to have to also submit, you need to show all work. So you have to show all work. You're going to do number 1, number 2, and number 3. You're going to factor completely and you're going to solve. So factor and solve. Factor and solve. And turn in those 3. So you're going to have 3 in your notes and 3 is work. Title them separately for me, please, so I can tell what I'm looking at when you submit them. All right, you guys have a great day.